In this video, we'll take a look at problem number 36 from out of section 2.6. And the directions in the book in front of this problem, and I forgot to copy them to just above where the problem statement is, but the directions said to refer back to example 6.6 before doing this. And basically in example 6.6, what they define is they define the current in a circuit to be the rate of change of charge. And whenever we've seen rates in calculus, we've always connected them back to derivatives. So current in a circuit is the rate of change of total charge. So rate is going to imply derivative. So current is usually used, the letter capital I is usually used to denote current, and I is going to be equal to the rate of change of charge, and Q is used to denote charge, so I is going to be equal to Q prime of T. So in number 36 here, what we want to do is we want to use this charge function that's given to compute a current function, I, which is just the derivative of charge, and then we want to use that new current function to find the current at 0, find the current at 1, and then just compare the two. So the derivative should be pretty simple here. I is going to be given by Q prime of T, and Q prime of T, given what we know Q to be equal to here, is going to be, well, 4 is a constant within the function, so it's going to be a constant within the derivative as well, and then I need to take the cosine of 4t's derivative. And I have an inner function here. My inner function is 4t. My outer function is cosine. So I'm going to have to use the chain rule to do this. And the derivative of cosine is negative sine. I need to leave the inner function inside of this though. So I'm going to have negative sine of 4t. And then to finish the chain rule, I need to multiply by the derivative of 4t, multiply by the derivative of the inner function. So I'm going to multiply by 4. The derivative of minus 3t is minus 3, and then the derivative of plus 1 is 0. So this would be our derivative. Now because we want to evaluate this derivative at 0 and at 1, it's going to be worth an extra couple seconds here to simplify this. I'm missing a grouping symbol here. I think I wanted my grouping symbol there. But simplifying this is going to really just amount to, well, 4 times a negative is negative 4 times this number would leave us with negative 16 sine of 4t minus 3. So there would be your formula for current. And then this current would be measured in amps. Now, if we wanted to use this to estimate the current at 0 and estimate the current at 1. It's not very difficult to do. I of 0 is going to correspond to I prime of 0, or excuse me, Q prime of 0, my fault. The derivative we just found is a derivative of Q, not a derivative of I. It's a formula for I. So we want to evaluate this at 0. So if we go ahead and toss 0 in place of the T, 4 times 0 is 0. If you think about the unit circle, sine of 0, I believe, is going to be 0, because if you draw your unit circle, at the angle 0, the y-coordinate of that point on the circle is 0. So yeah, this is going to be a 0, and we're just going to be left with minus 3. And if you try to evaluate the current at 1, you're going to run into a little bit of an issue if you're trying to do this without a calculator, only because this isn't going to be a nice angle whenever we try to locate it on the unit circle. Sine of 1, if you go to the unit circle, this is 0, this is pi by 2, which is about 1.57, so 1's going to be somewhere up in here. We're not going to be able to really use the unit circle to evaluate this. This would be something you'd want to evaluate on the calculator, and if you did, it can be estimated to be, I think, just a little bit above 9. Yeah, when I did this a couple minutes ago, I got 9.108 amps. So there's your current at t equals 0. There's your current at t equals 1. Both of those would be measured in amps. If you go into engineering at all, I can promise you'll be doing some stuff with charge, current, Ohm's law, stuff of that nature in the future.